The scientists planets, but despite all their efforts, haven't any so far. Isn't it very extraordinary that the universe is big, but our planet seems to be the only one, conditions right for life, and that it looks especially good?
Prior to 1995, there had been many attempts for the detection of planets and other stars, and these would be extrasolar planets, exoplanets. Every discovery proven to be subject to or just incorrect. In 1995, two teams planet around this was a real of a planet around a star. It was a very great sense of euphoria in the because for the first time we had techniques that are sensitive to other stars. In 1995, planets abundantly around, and many planets like easily. If you look at the statements made, for example, to national academies or to the Congress of the United States by America, a billion Earths just within our galaxy. But in fact, since 1995, as our techniques more improved, yes, what we have seen is thousands of planets. We have seen thousands of planets around other. But then when you ask the conditions, compare planets with, what you find is that planets, yes, but like planets, there essentially are not. Because the requirements for an Earth-like planet are many. The planet itself has to be in habitable zone, is a distance from the sun. Temperature of the planet is one in liquid water can at least somewhere on the planet. So if you're too close, you end up with is that there is excess heat, and the heat evaporates as a greenhouse. It's an effect that planetary geologists, the moist greenhouse, they run away, and water evaporates. When it evaporates, it gets to the edges of the atmosphere, where a particle sputtering essentially sends the particle of the sun, not the hydrogen, to the upper of the planet, desiccated. It doesn't just stay moist, it actually gets desiccated. On the other hand, if the planet is too far from the sun, the star, then the moisture will snow down on the surface, where the albedo, which is the planet, goes up. As that, the planet temperature drops, which causes more snowing, and you end up in a situation called the snowball Earth. Us on one end, snowball on the other end, and only in the middle is a. Now, calculations have been done, say, from the Earth, before I get into a runaway greenhouse. Some of these calculations put it at 1%. We're 1% closer into a runaway greenhouse. So we are very perfectly situated. And that's just from the distance. Then the point is that not all stars are the same. We have a very stable, energetic star. Stable star. If our the more common stars, like a M star, which would be a star, the habitable zone is closer. I have to be closer to be habitable, to have the moisture. But when I'm very close to a star, which is very M star, a lot of strong energy that also damages the planet. The other thing that happens is that the day and night cycles govern. As you get closer, there's a tidal action. It locks the planet, side of the planet, only the side that's seen. So the planet totally burns up, the other side just these are just of conditions together for